Hi everyone, in this video we're going to learn all about the standard normal. So in this distribution for x, we know it's distributed normally and then we see our first problem. We don't know what the population mean is. So let's always start by making a sketch of what we're looking at. Remember to label your x's because our distribution is called x. And here we have our first problem. We don't know what the mean is. We know the standard deviation is 3. But we have this extra bit of information which tells us everything below 16 has got to be probability of 0.9. So that's why I know 16 is on the right hand side of the mean, because everything to the left of it has to be 0.9. So it has to be most of the curve, the area of the curve. Now, as soon as you're in this situation, what you need to do is draw another one as identical as you can. It's my best attempt. But this time, we're going to use something called the standard normal. So the standard normal has slightly different parameters, and they're always the same. The mean will always be 0, and the standard deviation will be 1. So this is the z. If we try and create exactly the same picture, if we put a 0 here, what we're looking at is how many standard deviations above the mean gives us a probability of 0.9. So I forgot to write that there. So how many standard deviations above the mean we get 0.9? So if you go into your calculator, open up your normal distribution. If you're using the graphical calculator like I am, so you need to make sure your tail is correct. The x value isn't important. We know our x value is 16, but you'll see what I mean in a minute. So change your mean to be 0 and your standard deviation to be 1. Go across and sketch it. You'll probably find your whole curve is shaded in. But if you go across to the right and change your probability to 0.9, essentially creating this picture here I've drawn in blue and red, you get 1.2815. What that means is 16 is 1.2815 standard deviations from the mean. So we know one standard deviation is 3, so this 16 is a bit more than 3. So we're expecting a number around about 12. Now, so how do we use this? There's a coding formula you need to know, which is this. So the z-score, which we have down here, 1.2815, is equal to the score on your original, which is 16, on your distribution. Take away the mean, we don't know that, but we do know the standard deviation. So if you go back into your normal calculating mode and just type this in, bear with me, you get the mean to be 12.1555. I'm going to just round it to 2 decimal places, 4 significant figures, that's going to be it. So there you go. We can now answer any other questions they want to ask us about this distribution because we now have the population parameters. If we look at a different question, maybe it's the standard deviation we don't know. Exactly the same thing. Draw your picture of what you do know. So x is our distribution. We now know the mean is 12, and everything bigger than 15. 15 is a little bit more simpler because we have a number line. We already have the 12. And everything to the right of this line, the probability is 0.15. We can't use our calculator to find out anything because we don't have the parameters. So that is our cue to draw the standard normal. That's why it's a z. If you remember before, the mean is 0. And we want to work out how many standard deviations above the mean gives us the same probability of 0.5. Back to distributions. This time I'm going to have to change my tail. X value, just leave it the same. You should have the parameters already in your calculators. Remember to be pausing the video, make sure you're typing this in, make sure you're getting the same numbers, not just watching. And this is 1.281. Oh no, that's what it was before, because I haven't changed it. Skip those. It should be 1.0364. So using the same formula, I'll write it out again. So it's your z-score, it's your score originally, which we know is 15. Take away the mean, which we also know, but we don't know the standard deviation. So pop these numbers in. Cool, the little switcheroo on this one, much easier typing this one in. 3 divided by 1.0364. So the standard deviation is 2.8, so 3 significant figures. What about if both aren't given to you? So if you don't know both, then here's a picture of a hockey grip for the school I work for. And you're told the mean length is mu and the standard deviation is sigma. So we don't have either of them this time. But what we do know, let's define them. Let's go for that. So x is our random variable, the length of the grip. I'm going to just shorten it so I can get through this video a little bit quicker for you guys. So this is the situation we're in. We don't know either of them. So for x, we're here. But we do know 10% have a length less than 130. So there's 130, that's 10%. We know 150 centimeters, but to be longer than that, there's only a 5% chance. So here we go. If we start drawing our normal distribution, our standard normal distribution underneath, we know this is 0. This is still going to have the same probability. That's the bit we're interested in. And we can now find out how many standard deviations above the mean, no matter what it is, will give us these probabilities. So back to our distribution. I'm going to start with one on the left. So remember, you're trying to create the same picture on your calculator as you can see from the board, from your sketch. So for this one on the left here, I make that minus 1.281 standard deviations below the mean. I'm going to just keep the tail the same at 0.95. So I'm actually getting an inverted image. Just saves a little bit of time. So 1.6448. Right, so what we know is when we look at minus 1.281 standard deviations below the mean, that's a score of 130 minus mu. You'll notice I just skipped a step here. Normally I'd like divided by sigma, but it's just a bit quicker. And that it is what it means. It means it's 1.6448 standard deviations above the mean. So 1.6448 standard deviations is 150 minus the mean. Okay, so we have two simultaneous equations. If they're different signs, we add them. If they're the same signs, we're subtracting them. So let's go ahead and subtract these. So we get 20 here. Back to our home page. Bear with me while I type this in. Oh, I had a mare there. Hang on. 1.6448 plus 1.2. So I make this 2.9258 standard deviations would be 20. So let's go ahead and type this in. I make one standard deviation to be 6.835. That's the 3 decimal places. So now I'm going to sub it into this one here. So I'm going to times that by 1.6448, take it away from 150, and I make mu to be 138.76. So this question has a little bit more to it. It's not just finding the mean and standard deviation. They're now talking about 20 grips chosen. So when we're in the normal distribution and we're talking about a sample, it can go two ways. It could be a sample mean, but then it'd have to be talking about significance levels and sample means, which they're not. So now they're talking about 20 grips are chosen. They're actually talking about binomial distribution. So 20 grips are chosen, find the probability at least 4 of them are above 145 centimeters. Now, so I don't have to draw another picture. This is what we actually want. What is the probability it's greater than 145 centimeters? So back to our distribution. Tail pointing to the right, so greater than tail. We've got 145 as the value on our x. We now know the mean is 138.76, and we know the standard deviation is 6.836. Go ahead and let's work out the probability of that actually happening. So I have 0.1807. So let's just shift the along a little bit. So now I'm going to define my new random variable as y, and it's the number of grips. So number of grips greater than 145 centimeters, which means y is now distributed binomially to discrete valued number of grips. We have 20 grips, and the probability of it being greater than 145 is 0.1807. And the question is at least 4. So we need y to be more than or equal to 4. So let's just go into, at this time, our binomial distribution. Make your tail match up the question. Remember, because it's more than or equal to, we don't actually have to do any manipulations. So make it 4, number of trials are 20, the probability is 0.1807. Over we go, and you basically get 0.5. So it's 0.5007. And that is how you use the standard normal, and we only use it, just to reiterate, when we don't have the mean or we don't have the standard deviation.